This is my beginning algebra course. Today we're going to learn how to solve systems of equations. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. These expressions are called systems of equations. Each color is an example of a system of equations. The reason that these are called systems of equations is because you have more than one equation. You have, in this case, two equations for each one of these systems. You're going to learn how to solve systems of three equations when you take intermediate algebra. But in this course, we're only going to learn systems of two equations. Furthermore, you can see that in these systems, there's actually two variables. For example, in this first system, we have y and we have x. Now, if we had one equation with two variables, we probably would not be able to find what the variables are, but because we have two equations, we can figure out what x and y are. Or that's what we need to do in these systems is find x and y. So again, when you're solving systems of equations, you have to figure out x, y, and any other variables that may be present in the system. But again, in this class, we only have to figure out two variables. So we have to identify x and y. Now there are two methods for solving systems of equations, two primary methods: substitution, which we're going to learn now, and elimination, which we're going to learn later on in this class. So let's learn substitution. Substitution is a useful method when one of the variables in one or more of the equations is solved for. So you see how this y is by itself? That means that substitution is probably going to be the best method to solve this system. Here we have x by itself, and over here we have y by itself. So whenever you have a variable that is isolated in one of the equations or both the equations, substitution is the best method to use. Now here's an example where neither y nor x are isolated. Here's a system of equations where neither y or x is isolated. So that's just an example of an equation where you don't have that situation. Y has a bunch of stuff next to it, x has a bunch of stuff next to it. So in that example, substitution would not be the best method. We would use elimination, which we're going to learn later on in the class. So again, if you see a letter by itself on one side of the equation, that tells you to use substitution. So let's learn how to use substitution. So this is the equation where a variable is isolated, the y is isolated. So we're going to take the other equation, the equation where y is not isolated, and we're going to rewrite that equation. And notice that I put an arrow. I guess I'll just put a black arrow because you're not going to have different colors. You might have different colors, but so I'm putting my arrow there to show that we're taking this equation and we're rewriting it. But instead of writing y, I'm going to write 2x. Now, do you see why I did that? I know, because y is isolated, I know that y is equal to 2x. So when I rewrite this equation, instead of writing y, I can just write 2x because I know that 2x is equal to y. Do you see that? Now you're probably thinking, okay, who cares? What's the big deal? So what? Well, the reason that this is useful is because look at this equation. There's no more y. So that means that we can solve this equation using the methods that we learned in previous classes or previous courses. So the reason it's called substitution is because we substituted we substituted 2x for y. All right, so now we just solved this equation. Again, it was useful to do that because we got rid of the y. Now we only have x's. So now we can simplify. 5x plus 2x is 7x. And then we just divide both sides by 7 Divide both sides by this, but divide both sides of this equation by 7, and you get -2. And again, I don't require you to show that step. Just write the result after performing the step. So as you can see, by using that method, we found x. Now don't rush forward because we haven't solved the system of equations yet. We still need to find y. But to find y, that's going to be really easy because we're just going to take this equation and we're going to draw an arrow to show that we're using that equation. And we could use this equation too to find y, but it's going to be so much easier to use the equation where y is solved for. So we're going to write y is equal to 2, and then instead of x, we're going to write what x equals. Now remember, when an x is right next to a letter, that means 2 times x. So that's why I put the parentheses here, because I have to multiply 2 times x, and x is -2. So maybe I should just keep those colors there. That might help. Well, actually, I don't want to confuse you. I'm going to take those away. So now we know that y is equal to whatever 2 times -2 is, and of course that is -4. So at this point we have solved the system of equations because we have x and y. So that's pretty much what we're going to be doing. Let me just double check that answer. -2, -4, that looks right. That's what we're going to be doing for the next 20 problems, is this method of substitution. So the problems are going to get progressively more difficult. But let's do a couple more of these together before you try one on your own. All right, so you can see here x is by itself on one side of the equation. So you take the other equation where x is not by itself, and you're going to draw an arrow. Now, you're probably wondering, do I have to draw these arrows? Well, yes, you do. In my class, you do. In my course, you have to draw these arrows because you have to show the reader what you're doing, where you're getting this information. So we're taking this equation and we're going to write this same equation, x plus y equals 4, but instead of writing x, we're going to write what x is equal to. So instead of x, I'm going to put 2 plus y because that's what x is equal to, and then plus y equals 4. You know what? I'm going to color code these. I just can't resist. I think that would be helpful. At least I hope it'll be helpful for you there. All right, so now, as you can see, we got rid of the x. So now we just have 2 plus y equals 4. So add those y's together. Y plus y is 2y. Subtract 2 from both sides. Well, this is just a two-step equation. So I'm going to just do both steps in my head. And we end up with 1. Y is equal to 1. Subtract 2 from both sides. You get 2y equals 2. Then divide both sides by 2. You get 1. All right, so then we're going to take the equation where x is solved for, because now we have to find x. It's always best to use the equation where x is solved for if you're looking for x, of course. And we know what y is, so we just plug in y here. And so x is equal to 2 plus 1, because y is 1. So x is equal to 3. Okay, so now on to number 3. We're going to take the equation where a letter is solved for, y is solved for, it's isolated, it's by itself. Whoops, nope, sorry about that. We're going to take the other equation where it's not solved for, and we're going to rewrite that exact equation, but instead of y, we're going to put what y equals. So instead of y, we're going to write, we could write plus -6x. That would probably be a lot easier for you to understand, but I'm not going to do that because it's just unnecessary. I'm just going to write -6x. Again, that's the abbreviated notation. If you don't like that notation, too bad. You're just going to have to get used to it. I didn't make this stuff up, but you need to use the abbreviated notation. Get used to that because that's the notation most engineers and scientists are going to use. All right, so I took this y here, and I replaced it with -6. Hopefully that color coding is working for you. I should probably use the same color coding that I was using before, though. So there you go. Again, hopefully that's helping you. So now we just simplify this equation. -x minus 6x is -7x. And you can see that if we divide both sides by -7, we're just going to end up with 5 or -5 over 7. So now we have a fraction. So this problem is a little bit more difficult. So then we use the other equation where y is solved for, and we write y is equal to -6 times whatever x is. I'm going to move that over a little bit. Yeah. So -6 times whatever x is, and we know that x is -5/7. Now at this point, a lot of students are going to become very frustrated and very nervous and anxious because they don't remember how to multiply a whole number by a fraction. If you're nervous and anxious about that, don't worry. Remember, when you multiply a whole number by a fraction, you just write the whole number as over 1. So when you multiply fractions, you just multiply the numerator. 6 times 5 is 30, and 7 times 1 is 7. And we're multiplying two negatives, so multiplying two negatives would just give you a positive. So our two answers are -5/7 and 30 over 7. All right. So now we're going to go to the next problem, and it's time for you to try. So I'll try to leave those problems in the window. So try number 4, and when you come back, we'll do it together. All right, we're back. So we're going to take, this is the equation where y is solved for, so we're going to take the other equation and rewrite it. But instead of y, we're going to put what y equals, which is x plus 1. So again, instead of y, we wrote x plus 1. And this x was just rewritten there. Again, I don't know if these color coding techniques are working for you, but that's what's happening. We're using this equation. So x plus x is 2x, and now we have a two-step equation. So we just subtract 1 from both sides and divide by 2, and we get 2. X is equal to 2. And so if you got 2, good job. So now we use the other equation. So be sure to put your arrow to show which equation you're using. And we write y is equal to, instead of x, we write 2. And we can see that y is equal to 3. So if you got 2 and 3, good job. All right, try number 5. And when you come back, we'll do it together. All right, we're back. So this is the equation where a variable is solved for. You can see x is solved for, or isolated. Solved for is just another way to say isolated, by the way. So you take the other equation and you rewrite that equation, except instead of x, you write what x equals for y. Then you just simplify. And divide both sides by 6, and you get 2. So y is equal to 2. And then we use the other equation where x is actually solved for to find x. So x is equal to 4 times y, and we know y is 2. So 4 times 2 is 8, and we know x is 8. So if you got 8 and 2, good job. All right, so number 6 is going to be a little bit more difficult, but you can do it. Try number 6, and when you come back, we'll do it together. All right, we're back. This is the equation where y is solved for, so we're going to take the other equation. It's always the other equation where the variable is not solved for, and we're going to rewrite. But instead of y, we're going to write -1 plus x, and just rewrite the other parts of the equation. So y, I'm not really being consistent with my colors, but oh well. As long as you know what goes with what. So now we simplify this equation, and we get -1 minus 2x is equal to 1. And add 1 to both sides, divide both sides by -2, and you get x is equal to -1. And then we take the equation where y is actually solved for, and we plug in x to that equation to figure out what y would be. And I'm just going to use the abbreviated notation. And maybe I'll color code that just to be sure you know what's going on here. And y is equal to -2. So if you got -1 and -2, good job. Now I want you to be aware that you can check your answers to make sure that they're correct. In fact, you should probably always do that. And but I don't really have time to do it for every system of equations because we have limited time. But if you plug in -1 for x in this equation and you add -1, you should get -2 because y is -2, and of course you do. But that's not enough. We have to make sure that the variables work in this equation too. So we checked this equation. Now we can go to the top equation. And we have y is -2 and x is -1. So using order of operations, we have to multiply -1 times -3 first. And we get +3. And then we have -2 plus 3 is 1. And that worked out. So if you were confused by plugging in those numbers, then you need to go back to my pre-algebra course and study evaluating expressions. We can't do that in this course. We can't go over it in detail because it would take too long, and you should have already learned that. You may need some to brush up on it a little bit, though. That's okay. All right, so let's do number 7 together. Actually, you can do number 7. Go ahead and try 7, and when you come back, we'll do it together. All right, we're back. So x is solved for in this equation, so we're going to use the other equation. And instead of x, we're going to write 2y plus 1. So instead of x, we wrote what x equals. And so now we just have to simplify this equation. 2y minus y is equal to y. And then subtract 1 from both sides, and y is equal to 3. So now we go to the equation where x is solved for and plug in y. We know y is 3. We just figured that out. And 3 times 2 is 6. So therefore x is equal to 7. So if you got 7 for x and 3 for y, good job. All right. So why don't you try number 8, and when you come back, we'll do it together. All right, we're back. So this is the equation where y is solved for, so I'm going to take the other equation and I'm going to rewrite it, but instead of y, I'm going to write what y equals, and y equals 2x minus 1. So again, that goes here. And then just rewrite the other parts of the equation. Probably be best if I colored that entire part in there. I don't know if that's helping you at all. All right, so 2x plus 7x is 9x. And add 1 to both sides and divide by 9, and you're actually going to get 5/9. So we got a fraction this time. So now we go to the equation where y is actually solved for, or that variable is solved for, and y is equal to 2 times x, and x is 5/9 minus 1. So again, don't panic here. Multiplying a whole number times a fraction is not difficult. You just write the 2 as over 1. In fact, maybe I'll just rewrite that down here. I've got room. So any whole number can be written as over 1, no big deal. Then when you multiply fractions, just multiply straight across. 2 times 5 is 10. 9 times 1 is 9. Then all we have to do is 10/9 minus 1. And let me make some more room here. Now 1 can be written as over 1, and I can use the fundamental principle of fractions, multiply both sides of this fraction by 9, and I get 9/9. Obviously 9/9 is just 1, so 10/9 minus 9/9 is 1/9. Hopefully that's not too small for you there. And I forgot to rectangle that one. So if you got 5/9 and 1/9, good job. All right, so we're going to a slightly harder problem now. Again, this is substitution. That's the method that we're using. We're substituting one value for another value. So in these problems, it's the same method. We're going to find the equation where the letter is by itself, and we see x is by itself. So we take the other equation and we rewrite that equation. No difference whatsoever, except instead of x, we're going to plug in what x equals, which is 3y. Now, why did I put parentheses here? You tell me. Why did I put parentheses on the 3y? Well, I put parentheses because this here means 2 times x. If x is 3y, if I'm plugging in 3y for x, then obviously I need parentheses because I'm multiplying. I'm multiplying 2 times x, and x is 3y. So just be aware of that. You need to add those parentheses. So now we learned in pre-algebra that if you multiply 2 times 3y, well, that just equals 6y. You just multiply 2 times 3, and the y just hangs out there. So you can see where we're going at this point. Well, this is just another easy equation. Divide both sides by 7 and we get 1. Again, y plus 6y is 7y. And yes, this is 1y, even though the 1 is not there, in case you forgot from the last course. All right, so now we take the equation where x is solved for, the other equation, and we use that to find x. And instead of y, we plug in 1 because we know y is 1. And then x is equal to 3. So the only difference with this problem is that we plugged in a slightly more complicated expression because we had to multiply. And in fact, the coefficient in front of the x is really the only different part because we had to multiply 2 times our expression that we substituted. So, all right, so let's see here. We'll do one more of these together, just so you get the hang of it. So this is the equation where a variable is solved for. It's by itself. So we'll take the other equation and we'll rewrite that equation. But instead of y, we're going to write what y equals. And by the way, if you're tired of hearing me talk and you already understand this, then you can just go on and solve the problem and fast forward through me talking if you want to attempt all this. But just make sure that you look at my answer after you're done. Because if you do something wrong, you need to go back and look and see what I did. All right. So now we're going to multiply negative 3 times negative 4x, and that is positive 12x. And 12x plus 8x is 20x. And divide both sides by 20, and we get 1 over 20. So we have a fraction this time. So now we draw an arrow from the other equation. We have to use the other equation now, and we just plug in x. Negative 4 times 1 over 20. Negative 4, and then x is 1 over 20. So again, don't panic. 4 is just 4 over 1. And to multiply fractions, you just multiply the numerators. 4 times 1 is 4. And 1 times 20 is 20. And of course, we have to reduce that fraction. If you don't reduce your fractions, and you become an engineer or scientist, they're going to laugh at you because you're not reducing your fractions. Don't blame me. They'll laugh if you don't reduce your fractions, because why would you deal with these numbers when you can make them smaller? Divide both sides by 4. 4 divided by 4 is 1, and 20 divided by 4 is 5. So our answers were 1/20 and negative 1/5. All right, it's time for you to try. Try number 11. When you come back, we'll do it together. All right, this is the equation where a letter is isolated. It's by itself. So we're going to take the other equation where the letter's not isolated, and we're going to rewrite that equation. No difference whatsoever, except instead of x, we're going to write what x equals, 5y. And, yep, that looks correct. Now we're going to multiply negative 2 times 5y, which is negative 10y. (7y minus 10y is negative 3y. Divide both sides by negative 3, and you get negative 2. So if you got negative 2, good job. So now we draw an arrow from this equation, and please draw your arrows. You need to be drawing your arrows. If you didn't do that, go back and draw them. And we just plug in y to that equation. And x must be negative 10. So if you got negative 10 and negative 2, good job. All right, try number 12, and when you come back, we'll do it together. All right, we're back. So this is the equation where one of the variables is by itself. So we take the other equation, and we rewrite that equation. No difference whatsoever, except instead of y, we put what y equals. Y equals negative 9x. So I wrote this exact same equation, but instead of y, I wrote what y equals. All right, so now we're just going to continue. Negative 7 times negative 9x is positive 63x. And we're going to add negative 8x and 63x, and we're going to get what looks to be 55x. And then we're going to divide both sides by 55, and we get 4 over 55. And that cannot be reduced. So that's x. So if you got that answer for x, good job. Now we draw an arrow from the other equation, because we're using the other equation now. We have to find y. Y is equal to negative 9 times x, and x is 4 over 55. And again, don't panic. Negative 9 is just over 1. So by now in your math education, you should start to realize that whenever you multiply a whole number by a fraction, you just multiply that whole number into the numerator and don't do anything to the denominator. Hopefully you're understanding that by now. So negative 9 times 4 is negative 36, and 1 times 55 is 55. So y is equal to negative 36 over 55, and that cannot be reduced. I know it can't be reduced because 9 and 4 and 55 is 5 times 11. There's no common factors here, so we can't reduce that. All right, so if you got those answers, good job. All right, so now we're going to do a slightly harder type of problem, but it's the same procedure. So in this equation, y is isolated, y is by itself. So we're going to take the other equation and rewrite it. But instead of y, we're going to write what y equals. Instead of this y, we're going to write what y equals, which is 2x plus 1. Equals 4. And so I just rewrote this entire equation here. It's the same exact equation, but instead of y, I wrote 2x plus 1. So now we have an equation with parentheses. You might recall from my pre-algebra course, the course before this one, that when you have an equation with parentheses, you have to get rid of those parentheses first. And in fact, we kind of did that in the previous problems. We had parentheses here. We got rid of those parentheses by multiplying. But in this case, we're going to have to use the distributive rule to get rid of those parentheses. So I'm going to distribute 2 times 2x and 2 times 1. So I'm just going to rewrite that negative 3x. 2 times 2x is 4x, and 2 times 1 is 2. So now I got rid of the parentheses. And negative 3x plus 4x is x. And subtract 2 from both sides, and we get x is equal to 2. So if you got 2, good job. Now we're going to go to the other equation where y is solved for, and we're going to plug in x, because we know x is 2 now. And you got to use order of operations. Please don't forget to use order of operations. We have to multiply first, then add. Remember, order of operations, PEMDAS. You should know that by now. If you don't know PEMDAS, go to my previous course where we learned how to do order. We learned how to my pre-algebra course. We learned how to evaluate expressions. And you can also look at my arithmetic course where we learned order of operations. So 2 times 2 is 4, and 4 plus 1 is 5. So again, that problem was just a little harder because we had this more complicated expression, the 2x plus 1. All right, so this is the equation where a letter is by itself. So we're going to take the other equation, and we're going to rewrite that exact same equation, no difference whatsoever. But instead of x, we're going to write 3y minus 4. So again, I rewrote this equation. I wrote the exact same thing, but instead of x, I wrote what x equals, which is 3y minus 4, according to the top equation. So everything looks correct. Now we got to use distribution to get rid of the parentheses. Negative 2 times 6, or negative 2 times 3y is negative 6y. Negative 2 times negative 4 is positive 8. And so now we just combine the variables. Negative 6y plus 7y is y. And then we're going to subtract 8 from both sides. And we get negative 2. So now we take the other equation, and we use that to find x. X is equal to 3 times y, but we know y is negative 2. And 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. All right, so on to number 15. Again, you have to use distribution to get rid of those parentheses. So why don't you try number 15, and when you come back, we'll do it together. All right, we're back. So this is the equation where y is solved for. I'm going to take the other equation and rewrite it, except instead of y, I'm going to write what y equals. And now I have to use distribution. Negative 2 times negative 4x is positive 8x. And negative 2 times negative 1 is positive 2. X plus 8x is 9x. And subtract 2 from both sides and divide by 9, and you get 3/9, which is equal to 1/3. Using the fundamental principle of fractions, divide both sides by 3. All right, so now we're going to take the other equation where y is solved for, and we're going to plug in the x value, which we just figured out is 1/3. Now, negative 4 times 1/3, I'm not going to show that again and again and again. Obviously, it's just going to be negative 4/3. Again, you just take the whole number, multiply it into the numerator. So negative 4/3 minus 1, I'm going to write that as 1/1. And so I can use the fundamental principle of fractions, multiply both sides of that fraction by 3, and I get negative 4/3 minus 3/3, which is obviously negative 7/3. I'm sorry, I'm going to have to allow for more room here. Y is equal to negative 7/3. So if you got 1/3 and negative 7/3, good job. I'm sorry I gave you one that was a little more difficult to start out with, because we got fractions on that problem. That's okay though. All right, try number 16, and when you come back, we'll do it together. All right, we're back. This is the equation where x is solved for. So we're going to take the other equation and rewrite it. But instead of x, we're going to write 3y minus 2. We're going to use distribution to get rid of the parentheses. We're going to add the y's together. We're going to subtract 6 from both sides, divide both sides by negative 2, and we get negative 1. So we got negative 1. Good job. All right, now we're going to use the other equation to find x. X is equal to 3 times y, but we know y is negative 1. 3 times negative 1 is negative 3, and negative 3 minus 2 is negative 5. So if you got those answers, Good job. All right, on to number 17. Go ahead and try 17, and when you come back, we'll do it together. All right, we're back. Y is solved for in this equation, so we're going to use the other equation. Except instead of y, we're going to plug in what y equals in the other equations. That would be 5x plus 2. And now we're going to use distribution to get rid of those parentheses. Again, 2 times 5x is 10x, and 2 times 2 is 4. 2 times 5x is 10x, and 2 times 2 is 4. And we're going to simplify. And then we're going to subtract 4 from both sides and divide by 7, and you get x is equal to 1. So if you got 1, good job. Now we're going to use the other equation to find y. Y is equal to 5 times x, but x is 1. And we're just using order of operations, and we get y is equal to 7. Now again, if you want to check your answer, you just plug in 1 here. Negative 3 times 1 is negative 3. And plug in 7 here. So 7 times 2 is 14. So we got negative 3 here when we multiplied. We got 14 here. Negative 3 plus 14 is 11. So it works. Then we have to plug it in here. X is 1. 1 times 5 is 5. 5 plus 2 is 7. So is y 7? Yes, it is. So that worked. You have to plug it into both equations to verify that it worked. Again, we're not going to have time to do that for every one of these problems. And again, if you're having trouble plugging numbers back in, that means you're having trouble with evaluating algebraic expressions. You need to go back to my pre-algebra course and look at the class on evaluating algebraic expressions. All right, so let's do this one together. This is the equation where x is solved for, so we're going to take the other equation and rewrite that equation. But instead of x, we're going to write 2y minus 4. So again, we just rewrote this equation, but instead of x, we wrote 2y minus 4. Because we know x is equal to 2y minus 4. Now, this problem is a little different because we're just subtracting this expression. You can consider this number here to be 1. It's negative 1 times the expression here, 2y minus 4. So it's just a distribution again. Just consider that number to be 1, even though there's no 1 written here. In fact, just so that there's no confusion, I'm going to go ahead and rewrite that. All right, so use distribution to get rid of the parentheses. Negative 1 times 2y is negative 2y. And negative 1 times negative 4 is positive 4. So as you can see, the signs just change when you have a negative 1 in front of that those parentheses. So now combine the y's, subtract 4 from both sides, and you get negative 5. So if you got negative 5, good job. And of course we use the other equation. And I'm going to have to write, I'm going to have to throw everything in pretty quickly. Do all the calculations in my head because we're running out of room. Negative 5. And we get negative 10 minus 4 is negative 14. Actually, I just remember we're doing this one together, so I was congratulating you, even though you didn't do that one yet. So we'll do the next. You can do the next one. Actually, let's do this one together. We'll do one more of these types of problems together. Again, the only difference with these problems is that you have a 1. You have to write your 1 there because we're just subtracting an expression, which means -1 times the expression. So this is the equation where y is solved for. Whoops. This is the equation where what? My computer likes to jump around like that. This is the equation where y is solved for. So we're going to use the other equation. But instead of y, we're going to write 1 minus 4x. And so then we just simplify. Again, this is written as -1 times 1 minus 4x. You don't really have to write this -1 if you don't want. I'm just doing that to show you what's going on here. And use the distributive property to get rid of the parentheses. -1 times 1 is -1. -1 times -4x is positive 4x. X plus 4x is 5x. Add 1 to both sides, divide both sides by 5, and you get 1. So x is equal to 1. And of course we use the other equation to find y, plugging in x. And y is equal to -3. All right, so now it's time for you to try. Again, you can add that -1 if you want, but you don't really have to. So try number 20, and when you come back, we'll do it together. All right, we're back. So this is the equation where a letter is solved for. It's isolated. X is isolated. Take the other equation and rewrite it, but plug in what we know for x. You can add that -1 there if you want, if it helps you. Use the distributive property to get rid of the parentheses. -1. Well, I don't have to explain it again. All right, so -y minus 2y is -3y. Subtract 7 from both sides, divide both sides by -3. And there you go. So if you got -1/3 for y, good job. Now we use the other equation to find x. And 2 times -1/3 is -2/3. I can see there's some math here that we haven't done yet today, so hopefully you didn't get too bogged down with that. You can write that whole number as over 1 and multiply both sides of this fraction now by 3 to get -21/3. And now -21/3 minus 2/3 is -23/3. So x is equal to -23/3 and y is equal to -1/3. So if you got that answer, or those answers, good job. Try number 21, and when you come back, we'll do it together. All right, we're back. So y is solved for. It's by itself on one side of the equation. So we're going to take the other equation and rewrite it. But instead, we're going to plug in what y equals. Whoops. And again, we can consider this negative to be -1. Use the distributive property. Whoops. That's x minus 9x, which is -8x. Subtract 2 from both sides, divide both sides by -8, and you get x is equal to -1. Then use the other equation as usual. Y is equal to 9 times -1 plus -2. Nine times -1 is -9, and we get -11. So if you got -1 and -11 for your answers, good job. So we are now done with substitution. Again, that was called the substitution method because you would substitute one expression for a variable. So instead of writing y, we wrote -2 plus 9x in its place. Again, it's called substitution. So now we're going to learn the second method, and that is elimination. We use elimination when one of the letters is not solved for, when one of the letters is not by itself. You can see in these equations there is no letter that's by itself. There's no letter that's isolated on one side of the equation. So there's a different method to solve these problems. You could just go ahead and solve for one of the variables. You could do that by putting this 2x on the other side. Y would be by itself, and you could use substitution. But why would you do that if you can find an easier method? So for these equations, what we're going to do is we're going to notice that on the x's, we have coefficients. Remember, coefficients are the numbers right next to the letters. We have coefficients that are exactly the same. We have 2's. The only difference is one 2 has a negative and the other 2 is positive. So what that means is we can just add them together. And to show the addition, we're going to write an addition line there. And we're going to add these two numbers and these two terms and these two terms and these two numbers. And so negative 2x plus 2x, they just eliminate. They go away. That's where the word elimination comes from. That's why this works, is because negative 2x plus 2x is just 0x. But you don't have to write the 0x. Then we add these together. 3y plus y is 4y. And then we add these together. Negative 3 plus 7 is 4. Then we just take this equation, divide both sides by 4, and we get y is equal to 1. So as you can see, it's very easy. And to find the x value, we just plug it back in to one of these equations. But before we do that, I want to just talk about why this works. So we know that this side of this equation, this first equation, we know that this expression is equal to negative 3. we know that we can add something to both sides of an equation and it doesn't change the truth of the equation. So if I add negative 3 to both sides of this equation, the equation remains true. But because I know that negative 2x plus y is equal to negative 3, I can add negative 3 on this side and this expression on this side, and the equation remains true. So that's why we're adding these terms together to get 4y and these numbers together to get 4. Now, if you didn't understand that, that's okay. Most students don't understand it, to be honest with you. They don't even think about it. As long as you know how to do it, that's all that's required at this point in your education. So that said, and by the way, usually I don't want you to mess up the original problem, but you can see that this fraction line didn't really mess up anything. The original expression is still there, so that's okay to put that fraction line. You don't have to rewrite the equation just to write that line. All right, so finding x is going to be a little bit more difficult than the previous problems, the second step. Finding the other variable, that is, because we're going to actually have a two-step equation. Actually, I guess it's not going to be that bad. So we're going to take this equation. We can take any equation we want, but I'm going to go ahead and take this top equation, and I'm going to rewrite it, but I'm going to plug in 1 for y because we know what y is. We just figured out what y is. And then I'm just going to solve this equation. It's a two-step equation. So subtract 1 from both sides, you get negative 4, divide both sides by negative 2, and you get positive 2. So we are now done. We figured it out. So that is elimination. These are the easy problems. They're going to get a little harder, but we'll keep doing these easy ones now. So you see how these coefficients here are exactly the same? So all we have to do is just add these two equations together. 2x plus x is 3x. I'm going to move it down a little bit. 3x. And these cancel out when you add them together because one's negative, the other's positive. And 5 plus negative 2 is 3. So we have 3x is equal to 3. Divide both sides by 3 and you get x is equal to 1. So now we're going to choose one of these equations. I think I'm going to choose this one, I guess. Again, you can choose either one, whatever's simplest. So then we're going to plug in 1 for x because we know x is 1. And then we're just going to solve the equation. So we're going to subtract 1 from both sides, and then we're going to divide both sides by negative 3, and we get y is equal to 1. So as you can see, this method is pretty easy. All right. So let's try one more of these before you try one on your own. So we have variables with the same coefficients. The only difference is we have 1 here and a negative 1 here. Now notice that those 1s are not written. Remember, when you have an x with a 1 in front of it as the 1 as the coefficient, we just don't write the 1. So we're going to add these together. When we add these, they're going to cancel out. When you add these, you get 5y. And when you add these, you get 5. Divide both sides of this equation by 5, and you end up with 1. So there you go. Whoops. I'm sorry, I messed up there. That should be negative 5. It's always good to look back on your work there before you jump ahead too far there. All right. So now we can plug in negative 1 to y in one of these equations. I'm going to choose the first equation because it looks a little simpler to me. Just be sure that you write all the correct notation. That's all notation you should have learned in my pre-algebra course or whatever pre-algebra course you took. Negative 2 times negative 1 is positive 2. And subtract 2 from both sides and you get negative 1. Yep, looks like that's correct. All right, so time for you to try now. Try 25, and when you come back, we'll do it together. All right, we're back. So we write our line to show that we're adding. So we add these two together, you get 0, they cancel out. Add these two together, you get 3y. Add these two together, and you get 3. Seems like our answers are 1 quite a bit. Now we take one of these equations, doesn't matter which one, I'm just going to take the bottom one, and we plug in 1 for y. And then we just solve. Subtract 2 from both sides, divide both sides by 5, and you got x is equal to 1. So if you got 1 and 1 for your answers, good job. All right, try number 26, and when you come back, we'll do it together. All right, we're back. We're going to write our line to mean that we're adding, and we get 5x is equal to negative 5x, and we got 1 again, except negative 1. So we got negative 1. Good job. Now we're going to plug it into one of these equations. I'm going to try the top equation this time. 2 times negative 1, because x is negative 1. And simplify before we do anything. Add 2 to both sides, divide both sides by 7, and you get 1. Now again, notice that I'm not showing these steps. I'm just showing the result after you perform the steps. Why? Because you learn how to do these steps in pre-algebra. I don't need to see them. All right. The work would just become way too tedious if you had to show those steps. Try number 27, and when you come back, we'll do it together. All right, we're back. Write your little line there and add the numbers, and you get 11x is equal to 11x, and we just happen, whoops, not 11x, just 11. Just so happens that x is equal to 1 again. And I'm going to plug in 1 to the bottom equation. And let's see here, 2 plus y is equal to 4. Subtract 2, and you get y is equal to 2. So if you got 1 and 2, good job. All right, try number 28, and when you come back, we'll do it together. All right, we're back. Draw your little line there. Divide both sides by 17, and if you had trouble with 17 divided by, or 34 divided by 17, just get out your calculator, no big deal. Now I'm going to use the top equation to find x. And I'm plugging in y. And now we just simplify. Subtract 20 from both, or subtract 18 from both sides, and divide both sides by 10, and you end up with 2 over 10, which reduces to 1/5. I'm going to bring that down a little bit. So x is equal to 1/5. So if you got 2 and 1/5, good job. Try number 29, and when you come back, we'll do it together. All right, we're back. Draw your little line there. X is equal to negative 4. That was an easy one. Now we have to plug in negative 4 for x. I'm going to use the top equation. Add 16 to both sides, divide both sides by 8, and you have y is equal to 2. So if you got 2 for y, good job. All right, so now we're going to go to something a little bit more difficult. I want you to understand that, again, we're using the second method. We used the first method, which was substitution. The method that we've been using in the last 5, 6, 7, 8, 9 problems is elimination. But I want you to understand very clearly that in all these problems, I was careful to make a coefficient the same on one of the variables. You see that? But opposite sign. See how they're the same here? 7, 7, 1, 1, actually negative 1, 1, negative 5, 5. So those are special problems. We could just add them up and they would just eliminate immediately. These 10s would just eliminate, these 8s would eliminate, so on and so forth. But look at this problem. You have a 4 and a 3, those are not the same. And you have a 1 and a negative 2. Those are not the same. So we got a big problem here. How can we add them up? If we add them up, we're just going to get 7x, and you add these two together, you get negative y, but nothing eliminated. You see, you still have two variables. So adding these two equations is not going to do anything for you. Do you understand that? Do you get that? Adding these two equations is going to produce this equation, and nothing eliminates. So the elimination method doesn't work. So we have to do something first. We're going to have to change one of these equations so that the two coefficients are the same. So what we're going to do is we're going to multiply this top equation, both sides of the top equation, by 2. Because I want a 2 right here. I have a negative 2 here. So in order for them to eliminate, I need a positive 2 here. You see that? But I can't just put a 2 there. I can't just write some random 2 there. Then I'll change the expression. So in order to make this equation, or to keep this equation true, if I want a 2 here, I have to multiply a 2 into all the other numbers. So let me demonstrate. You're going to take, I'm going to have to show this step here. I'm going to multiply both sides of the top equation by 2. You see that? I multiplied this side by 2 and I multiplied this side by 2. And let me just draw a line to show you where I got that equation. So, and then I'm just going to rewrite the bottom equation. It's very important to understand that when you change the form of a system of equations, because that's all I'm doing is I'm just changing the form of one of these equations. When you change the form of a system, you have to take the entire system with you. So that's why I had to rewrite this equation also. These two equations are joined. They cannot be separated in this particular context. So now I'm going to use the distribution property, and I get 8x plus 2y equals 10. And I'm going to rewrite the bottom equation. Again, the bottom equation didn't change. So again, the bottom equation didn't change. But the top equation changed because I multiplied both sides by 2. And I had to use the distribution property. 2 times 4x is 8x. 2 times y is 2y. So in case you're becoming really nervous and angry that I'm going so slow here, I'm going slow on purpose. I'm not going slow because it takes a long time to do this. I'm just showing you every step. So at this point, look what happened. Do you see what happened here? We now have 2 and negative 2, so now we can eliminate. We couldn't eliminate before, but now we can. So we're going to write that fraction line, and I'm going to get rid of this fraction line up here because we can't use that on that system. So now we add these two equations together just like we did in the previous problems, and we've got 11x equals 11. Divide both sides by 11, and you have x is equal to 1. Then we're going to go to any one of these equations. It doesn't matter which one. I'm gonna choose this top one up here. Actually, you know what? I can't really do that. It'll be hard to see what's going on, so I'm going to choose the bottom one. And we plug in 1 for x. And then if you solve, you get y is equal to 1. I don't really have any room to show all that work, but hopefully by now you kind of get an idea of what's going on. So that method is often called the multiplication elimination method, because you have to multiply one or both of the equations first, then you eliminate. So again, I just want to recap here. These two, we didn't have a similar coefficient, or the same or opposite coefficient, so we had to multiply the top equation by 2, and that changed it to this equation. Now we have similar coefficients, and we just add them together. So again, if I want a 2 on this y, the only way for me to do that is to multiply both sides of this equation by 2. Unless, if I don't do it that way, then it changes the solution. All right, so now I'm going to start to speed up here because I don't want you to think that it takes, a long time to solve these. It really doesn't. So again, we cannot eliminate. We need these coefficients to be the same. So if I multiply the bottom equation by 3, then we're going to get, I'm just going to rewrite the top equation. And we're multiplying the bottom equation by 3. So we have to multiply everything by 3. So we're going to use distribution. Again, I'm going to just rewrite the top equation. The top equation is not changing at all. But I have to bring these equations down together. So again, whenever you're using the method of elimination and you have to multiply, you got to bring both equations down together, because they have to move together. All right, so that looks right. So now we have a negative 6 and a 6. So now we can add them together, and we end up with 2y is equal to 2 and y is equal to 1. A lot of solutions in these systems are 1. It just makes it easier to do the math. That looks right. So now we just plug in y into one of these equations. And I'm going to choose the bottom equation. So 2x minus 3 times 1, because y is 1. We just figured out y is 1. 2x minus 3 is equal to 1. And of course, x is equal to 2. Again, I know I'm skipping steps there, but that's pre-algebra stuff. All right, so let's try one more of these before you try some on your own. So I'm going to multiply the top equation by 2. Or both sides of the top equation by 2. I should clarify. There's no such thing as multiplying an equation. You have to multiply both sides of the equation. That looks right. So now we have, using distribution on the top equation, we have 10x plus 2y equals 12. And again, I'm just going to rewrite the bottom equation. I just keep rewriting the bottom equation. So now you can see we have a 10x and a negative 10x, and we did not mess up the equations because we multiplied both sides. The equation is still true. All right, so now we're going to add them together, and we get 5y is equal to 5. Y must be equal to 1. Then I'm going to use the top equation. Plug in 1 for y. Subtract 1 from both sides, divide both sides by 5, and you get x is equal to 1. Alright, so hopefully you got the idea there. Go ahead and try. You have to figure out which equation you're going to multiply. What would be easiest? I'll give you a hint. The top equation you're going to multiply by something, and you're going to eliminate the y. So that's the hint. Try number 33. When you come back, we'll do it together. All right, we're back. So we're going to rewrite the system, but I'm going to multiply the top equation by 3. And just rewrite the bottom equation. Again, in this context, when you're eliminating, the equations have to go together. You can't tear them apart, break them apart. Everything looks right, so now I'm going to use distribution in the top equation. And now we're going to add, and we can see that these y's are going to cancel out. So we end up with 11x is equal to 22, it looks like. And divide both sides by 11, and you get 2. So if you got 2 for x, good job. I'm going to use the bottom equation here to find y. So 2 times 2 minus 3y equals 13. And that's going to be 4, and then we're going to subtract 4 from both sides, and then we get 9. Divide both sides by negative 3, and we get negative 3. Now if I have any doubt in that, I can just plug the answers back into both these equations and see if the equations are true. And 6 minus 3, that looks correct. And 4 plus 9 is 13. That looks correct. So I checked it, and it worked. So if you got those answers, good job. All right. So you have to figure out, are you going to multiply the top equation or multiply the bottom equation? You could divide, but you divide both sides, but that would be harder because you'd end up with fractions. So go ahead and try 34. When you come back, we'll do it together. All right, we're back. I'm going to multiply the top equation by 2. Use distribution. On the top equation, we use distribution. And now we're ready to add because we have coefficients that are the same but opposite. Same coefficients but opposite signs. Divide both sides by 13, and we know y is equal to 1. So we got 1 for y. Good job. Now I'm going to use the top equation to find x. And we simplify. Subtract 5 from both sides, divide both sides by 2, and we know x is equal to negative 2. So we got negative 2. Good job. All right, try 35, and when you come back, we'll do it together. All right, we're back. So I'm going to just rewrite the top equation. And I'm going to multiply both sides of the bottom equation by 3. Everything looks right. Rewrite the top equation again. Use the distributive property on the bottom equation, and you get 15x plus 12y is equal to negative 27. And now you can see that we have coefficients on the x's that are the same but opposite. So they're just going to cancel out when you add them together. We're going to end up with 19y is equal to negative 19, looks like. Divide both sides by 19 and you get negative 1. So if you got negative 1, good job. And now I'm going to plug negative 1 back into the bottom equation I think I'll use to do this. So we get 5x plus 4 times negative 1 equals negative 9. Add 4 to both sides, divide both sides by 5, and you get negative 1. So if you got negative 1 and negative 1, good job. All right, so we have the same situation here, just with a slight difference. In these problems, we're going to have to multiply by a negative. So we can get rid of the y's or we can get rid of the x's. In some of these problems, you can get rid of either x or y. We can multiply both sides of this equation by negative 5, or we can multiply both sides by negative 2 if we want to get rid of the x's. Negative 5 if we want to get rid of the y's, negative 2 if we want to get rid of the x's or eliminate the x's. And so we have to multiply by a negative because these coefficients, let's say that we want to get rid of the x's, we multiply both sides by negative 2, then we're going to have opposite signs because now we have positive 2 and positive 1. So in order for them to eliminate, we need a negative 2 here. So we're going to have to multiply by a negative number. So it's really no different from what we were doing before. So I'm multiplying the bottom equation by negative 2. So use the just rewrite the top equation and use the distributive property on the bottom equation. And add the equations together because now we have coefficients that are the same but opposite. And we get 3y is equal to negative 3 and y is equal to negative 1. And I'm going to use this bottom equation because that looks really simple. X plus negative 1, I'm just going to use the condensed notation. So x is obviously equal to 2. So again, the difference for that problem is you have to multiply both sides by a negative. All right, let's do 37 together. We're going to multiply the top equation by negative 2. Actually, you know what? I'm going to get rid of y first, just because we got rid of, I think we got rid of x in the previous problem. Yeah, we got rid of x, so I'm going to get rid of y, because you can get rid of y too. If you, or you can use, eliminate the y's if you want to, so I'm going to go and do that. So I'm going to multiply both sides by negative 3. And let's see here. Use the distributive rule in the top equation. And then we're going to add. And you can see that I was successful when I multiply because these two coefficients are the same but opposite. And remember, negative x is the same thing as negative 1x. You don't have to write the negative 1 though. I'm going to go ahead and write it just to make sure that you remember what's going on there. Divide both sides by negative 1 and x is equal to 1. So now I'm going to use the top equation. Let's see, 1 plus y is equal to 3. So therefore y is equal to 2. All right, so why don't you try number 38. Number 38 and 39, the same situation. So try 38. When you come back, we'll do it together. All right, we're back. So I have to get a positive 9, so I'm going to have to multiply both sides of that equation by a negative 3. So I'm successful because I have a negative 9 and a positive 9. Add those up. And let's see here. Seems like this, wait a second. Whoops, I just found a mistake that I made. That should be negative 5, I'm sorry. Negative 3, so that should be positive 15, I'm sorry. So then you add them together and you get 14. Divide both sides by negative 7 and you got negative 2. So if you got negative 2, good job. I'm going to plug that negative 2 into the bottom equation. And simplify. Add 10 to both sides, divide both sides by 3. And you have negative 5/3. So, if you got those answers, good job. All right. Let me just double check that answer. It looks correct. Positive 15. Yep, that's correct. All right, try number 39, and when you come back, we'll do it together. All right, we're back. So I'm going to multiply the top equation by negative 2, and then I'll get negative 8 here. And we're ready to add them up. You get 9y is equal to 9 and y is equal to 1. That looks correct. And now we're going to plug it into, you can choose any one of these equations. I'm going to choose the bottom one. Simplify. We have x is equal to 3. So we got 3 and 1. Good job. All right, continuing on with these equations. Try number 40, and when you come back, we'll do it together. All right, we're back. I'm going to multiply the bottom equation by -7. That looks right. Add them together and you get -29x is equal to 58. And let's see here. If you divide 58 by -29, that should be -2, I believe. Yes, that's -2. All right, so I'm going to use the bottom equation here. And it looks like we don't have a lot of room here. 5 times -2 plus y is equal to -9. And I'm going to have to go up here. Then we have -10 plus y is equal to -9. Add 10 to both sides, and we have y is equal to 1. So if you got -2 and 1, good job. All right, try number 41, and when you come back, we'll do it together. All right, we're back. I want to multiply the bottom equation by -3. Because I got to change that sign to +6. Whoops, I got to multiply the right side of the equation too. All right. (6x plus 9y +15). Now we can add them together. I know I did it correctly because we have a -6 and a 6. And then we get 14y is equal to 14. Divide both sides by 14 and get y is equal to 1. And I'm going to use the top equation. -6x plus 5 times 1 is equal to -1. And I don't have much room, so I'm just going to do that in my head, and we end up with x is equal to 1. So if you got 1 and 1, good job. All right, so now we're going to the last type of problems here. Again, we learned substitution, and then we learned elimination. Elimination or substitution is when you're just taking one variable is solved for, and you just plug that, what that equals, into the other equation. That's substitution. And The other method, elimination, we have three different types of problems for elimination. One problem is when we just go ahead and add the equations together without doing anything because the coefficients, or some of the coefficients, are the same. But we had another type of problem where we had to multiply one of the equations so that we could eliminate, and then we could add them together and eliminate. But in this type of problem, we don't have we can't just eliminate one equation. We actually have to eliminate, or we don't have to multiply one equation. We have to multiply two equations in order to eliminate. Because if I try to get let's say I try to get a positive 5 here because I have a negative 5 here. If I try to get a positive 5 here, how do I do that? Well, it would get pretty difficult. So I can eliminate the x's or the y's. It doesn't matter which one. I'm going to eliminate the x's. So here we go. I'm going to multiply, and when you see me do this, you're going to start to understand immediately what's going on. You're going to multiply the top equation by 5. You're going to multiply the bottom equation by 2. And you can probably see what's happening here already. I'm going to put a divider here. Well, maybe I shouldn't do that. You might want to divide your problems up a little bit. Let's see here. Just making sure everything looks right. Everything looks right. And so now we have to use the distribution rule. On the top equation we have 10x and so on and so forth. In the bottom equation we have negative 10x. So now we're ready to go because I have 10 and negative 10x. So again, we had to multiply both equations to make that work. So now we can eliminate, add them both up, and we get, let's see, 23y equals 23, and y is equal to 1. And I'm going to take the top equation, don't really have much room here, plug in 1 for y. And I end up with x is equal to negative 1. So again, that's an equation where we had to multiply both equations. I like the fact that one of these terms has a negative on the y and the other one has a positive. So I'm going to just get rid of the y's because I don't want to have to multiply by a negative. If I tried to get rid of the x's, I'd have to multiply one equation by a negative because I have to change the signs in order to use the multiplication method. So I'm going to multiply the top equation by 3. And the bottom equation by 5. Use the distribution property on both equations, on the top equation and on the bottom equation. Do you see the 15s? They're going to cancel out now. Alright, so now we're ready to add them up. We get 67x. Maybe I shouldn't write those x's under there. 67x is equal to 67, it looks like. Divide both sides by 67 and we end up with x is equal to 1. You're probably wondering why we get 1 so many times in these problems. Well, it just makes it easier to design the problems if the answers are 1. You could make the answers anything, really. Now I plug that 1 back into one of the equations. I'm going to choose the bottom one. and we get y is equal to 2. All right. So we're going to try one more of these together where you have to multiply both equations. Again, there are elimination problems. We learned substitution. We're done with that. But now we're doing elimination. There are 3 types of elimination problems. There's elimination where you don't have to multiply either equation, you just add them together. There's a second type of elimination where you have to multiply one of the equations, then add them together. And then there's this type, the hardest type, where you have to multiply both equations and then add them together. But in this problem, something's different because all the signs are the same. They're all pluses. So that means we have to multiply one equation by a negative if we're going to add them together. I can eliminate the y's or the x's. What do you want to eliminate? You want to eliminate the y's or you want to eliminate the x's? It doesn't really matter. They're going to be about the same. If you want to eliminate the x's, you multiply both sides of this equation by 2. And you multiply both sides of this equation by -3. Or you could do -2 and +3 here. You get the same thing. If you want to get rid of the y's, you multiply both sides, or you multiply both sides of this equation by 5 or -5. And you multiply both sides of this equation by 8 or -8. I'm going to get rid of the x's because I think I got rid of the y's in the previous 2 problems. No, I got rid of the x's on the first ones. I think I guess I'll just get rid of the y's again. So I'm going to multiply both sides of the top equation by -5. And both sides of the bottom equation by +8. And everything looks right. Now we use the distributive property. -5 times 15, I think that would be -75. You can get out your calculator if you really want to, and then -40y, so on and so forth. And because these coefficients are opposite, the same coefficient but opposite, that's a good sign that we're on the right track. So now we can add them together. I should put the x's below. And x is equal to 1. So now I'm going to use the bottom equation. Again, you can use either equation on this part. So 10 times 1 plus 5y equals 5. And y is equal to -1. All right, so now it's time for you to try. I'm going to move this over a little bit. Again, you're going to have to multiply both equations in order to eliminate. And in case you're looking for a way to describe this, what you're doing is you're looking for the lowest common multiple of these two numbers. If you're gonna eliminate the y's, if you're gonna eliminate the x's, you're looking for the lowest common multiple of 15 and 10. In case you forgot what the lowest common multiple is, that's like if these are the denominators of a fraction, you're just looking for the lowest common denominator of these numbers. For example, if you're adding 3/8 and 1/5 for these two numbers, you're just looking for the lowest common denominator. So it'd be 40. So that's why we got those 40s. All right, so you can do it any way you want, but because we have a negative here, I'm going to eliminate the x's. So if you want to do it the way I'm doing it, go ahead and eliminate the x's, but you can eliminate the y's, and we'll see if we get the same answer. It's up to you. Try number 45, and when you come back, we'll do it together. All right, we're back. I'm going to multiply the top equation by 5. and the bottom equation by 3. And then use the distributed property. I don't know if I mentioned, but this bracket just means that the two equations are together. Probably should have mentioned that at the beginning of the class, but oh well. And we get 41y is equal to 41. Divide both sides by 41, and we get y is equal to 1. And I'm going to use the top equation to find x. Again, using order of operations, and we end up with x is equal to -1. So if you got those answers, very good. Try number 46, and when you come back, we'll do it together. All right, we're back. I forgot to tell you which, well, I guess it's pretty obvious. I'm going to do the ones that have opposite signs. That way I don't have to multiply by a negative. So I'm going to multiply the top equation by 3. And the bottom equation by 11. All right. And use distribution. Getting some big numbers here. You can get out your calculator if you don't want to do 11 times 11. All right. What in the world? How did I get it at 24? How did that happen? I'm sorry. That should be 33. Everything looks right now. All right, so adding up, these are going to cancel out, obviously. 18 plus 88, you can get your calculator if you're afraid to do that. 108, 106, it looks like. 106x. And negative 106. So x is equal to -1, dividing both sides by 106. We don't have much room here, so I'm going to try to do this in my head. In fact, I'm going to do it off to the side here because we just don't have a lot of room. So x is -1. Y is equal to -1. So if you got those answers, good job. Try number 47, and when you come back, we'll do it with, actually, wait a second. We have, these are all the same signs, so you're going to have to multiply one of these equations by a negative. Just be aware of that. I'm going to get rid of I think I'm just going to get rid of the x's on this one. It's probably better to get rid of the y's because we have a smaller number here. But I'm just going to get rid of the x's to mix things up. Try number 47. When you come back, we'll do it together. All right, we're back. So I'm going to multiply both sides of the top equation by -4. I can multiply the bottom by a negative or the top by a negative, just as long as one's negative and the other's positive. So you might have multiplied the bottom by a negative. That's okay. But don't multiply both equations by a negative because that wouldn't work because you get the same sign. And I'm going to multiply the bottom equation by 7. Use the distributed property on the top equation. And just double check everything. Everything looks right. You can see these are the same coefficient, so we can add them together now. Negative 12 plus 49. That's going to be 37. Negative 4 plus negative 70 is negative 74. And if you divide both sides by 37, you get a negative 2. You can confirm that with your calculator if you want to. Alright, so again, we don't have much room here, but I'm going to try to use the top equation. 7x plus 3 times y, and we know what y is. It's negative 2. That's what we just figured out. I'm going to put a divider here. And x is equal to 1. So if you got x, good job. Again, the reason the answers just keep being 1 is because it's just easier to make these problems if the answers are 1. But they're not always going to be 1. As you can see, sometimes the answers something other than 1. So we got those answers. Good job. I don't know if we have a lot of time to do these challenge problems here. We have 6 more problems, but the reason that I'm calling these challenge problems is because I think you're going to get fractions on these problems. So that's going to be they're going to be a pain. We can try to do a couple of these, or maybe just one. So I'm going to multiply both sides of the top equation by negative 5. And both sides of the bottom equation by 2. Alright, now we can add up. And as you can see, it looks like we're going to get a fraction. Divide both sides by negative 7 and we get 3/7. So that's why this is a challenge problem. Because if we have to plug this back into this equation, you can see that it's going to require some math. Just double checking to make sure that's correct. So now I'm going to take the top equation, and hopefully I'll have enough room because we're going to need a lot of room. So 2x plus 3 times y, but y is 3/7. So you can see why this is going to be difficult. So I don't have a lot of room here, so I'm going to 3 times 3/7 is 9/7. Again, you need to understand when you multiply a fraction by a whole number, it just multiplies into the numerator. 3 is just over 1. Multiply the numerators and the denominators straight across. Now I have to subtract 9/7 from both sides. And this is why this problem is difficult. because now I have to do 1 minus 9/7. I have to move that over a little bit. So 1 is just over. 1 is a whole number, so you can just write it as over 1. So then multiply both sides of this fraction by 7, and you have 7/7 minus 9/7. I don't think we're going to have time to get to these problems down here, so I can just move these down. In fact, I'm going to go ahead and just rewrite all this. Sorry about that. Because now I have enough room. Subtract 9/7 from both sides. The 1 over 1 becomes 7 over 7. And 7 over 7 minus 9/7 is negative 2 over 7. I'm just going to get rid of these equations altogether. Sorry about that. Having to move this stuff around. And then we have to isolate, so I'm going to rewrite. We don't usually rewrite for these problems, but since we're going to come up with a complex fraction here. Divide both sides by 2, but again, we have a complex fraction. So we dealt with those in the class on complex fractions. So this just means division. So we're going to change it to the old division sign. Maybe I should write that in red just so you can see what's going on. And this 2 is just over 1. You can just write it as over 1. So remember, when you multiply, or excuse me, when you divide fractions, you just change to multiplication. And I guess I can change that to a dot. And we have no room, so I'm going to go up here. And negative 2/7 times 1/2. You just multiply the numerators straight across, and we get negative 2 over 14, which reduces to, you divide both sides by 2, and you get negative 1 over 7. So you can see that's why it was a challenge problem, is because we ended up with a fraction. Hopefully you won't get a lot of those in your homework. We only had time to do one of those, so you can try some more of those if you want. It's really hard to check the answer also to see if you did it correctly, because you got to plug those fractions back in. So we don't have time to do that, but that was the class today. If you'd like to take screenshots of these pages, go ahead and do that now. So the first 2 pages and the second pair of pages. Whoops. Now don't go before you get your homework. Get a screenshot of these 2 pages. You have 16 problems, and remember to write your name, the date, the course, which is beginning algebra. Write a title, solving systems of equations, the homework. And remember, your homework needs to have those 4 characteristics. It has to be complete, correct, neat, and in order in your binder. And if you don't do the homework, then it's a 100% guarantee you're going to learn nothing from this class. So as usual, the answers are provided, but you got to show the work. You got to show how you got your answers. So get that homework done, and I'll look forward to seeing you in the next class.